everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. We will discuss about solving the problems regarding surface integrals. That is, first we will discuss in detail about definition of surface integrals, then problems based on surface integrals. First one is definition of surface integral. That is, a surface, that is r vector, which is equal to f bar of u comma v. That is, f bar, which is defined in terms of the variables u and v, and this curve is what is the surface, which is very smooth surface if f bar of u comma v is continuous and possesses partial derivatives. Then capital F, that is vector capital F, in terms of R. Already we defined in terms of R, what is that? That is a smooth surface. The smooth surface which is connected to our vector point function, that is vector which has the magnitude as well as direction. So now capital F of R over the region S of the surface R vector equal to f bar of u comma v, which is denoted by, that is double integral s f dot n ds. That is, here our f is nothing but vector point function, n is nothing but the unit normal vector which is perpendicular to our surface. Here the capital S, which it denotes, that is a surface integral. To evaluate the surface integral, double integral which is used. Now the ds, which is represent the surface, the totally xyz 3-dimension, in which any 2-dimension, the surface which lies in 2-dimension, so which the plane we are calculating. Suppose if we are calculating xy plane, the ds will be removed by dx dy. Suppose if we are calculating yz plane, then it is dy dz. Now we will concentrate surface integral solving problems. The first one is evaluate double integral s f dot n ds, where capital F equal to zi plus xj minus 3y square zk, and s is the surface, x square plus y square equal to 16 included in the first octant between z equal to 0 and z equal to 5. We can see here the surface, that is circle, a curved, that is what here which is given. The equation of the circle, x square plus y square equal to a square. So our radius is 4. So from the origin 0 to 4 it moves, and our complete the geometrical figure which lies in the first octant, and z is taking the value from 0 to 5. With this, we are going to calculate our surface. We can see it here, x square plus y square equal to 16. Next, we can see here the surface, the capital S is the curved surface. The geometrical figure, we can see it now, we will see now. Before that, what are the conditions which is given in the question we are writing here? That is, let pi equal to x square plus y square equal to 16. Capital F equal to zi plus xj minus 3y square zk. and pi also, which is written x square plus y square equal to 16. Z equal to 0 and z equal to pi. So the three-dimension figure, which is here, it is there, and it is named as, the origin is O. The coordinates, this is y-axis, here x-axis, and here z-axis. So we can see the curved, actually, the cylinder which is drawn here. The coordinates, we are giving the name A, P, the joining the points, the lines which are joining the points, and curves. So the complete A, B, E, C, E, A. So this is actually the cylinder figure in which the surface we are going to take here, YZ plane we are going to take, which is easy to calculate. Now we know it, x square plus y square equal to, which is given 16. If you put x equal to 0, then y square equal to 16, y is nothing but 4. So that's what here the coordinate 0, 4, 0, which is there. So the next one, the question itself which is given, that is from 0 to 5 which is given. That is, this is from 0 to, that is our O is our origin. From where 0 to, it moves up to 5. So from the figure itself we can easily see it. Here, from here, the Z dimension is there. Here, the role of Z is 0. So, which is equal to Z equal to 0. So, then the normal to the surface, S, is grade pi. First, we will find the normal vector. So, the normal vector is grade pi. The grade, the formula is I dou by dou x plus j dou by dou y plus k dou by dou z. The pi is outside. This is our condition which is given. That is a curved condition. X square plus y square equal to 16. So the next thing, the pi we are taking inside, then it has become dou pi by dou x plus dou pi by dou y plus dou pi by dou z. We want it dou pi by dou x. Already here pi is there. We have to do partially with respect to x. So x square. So partially with respect to x is 2x. Here I, j, k should be there because we are taking only pi. I, j, k retains as it is. That's what here I is there. So the next one is dou pi by dou y. So here what I am circling, y square. So the differentiation is 2y. This j, it is written as it is. Next one is dou pi by dou z. But here there is no z term at all. So completely it has become 0. So now unit normal vector. That is, this normal vector, we are going to convert it into unit normal vector. That is, this vector divided by its modulus. Now, in this, 2 is common, we have taken out. So 2 of xi plus yj divided by 2 of, here the I, this one is x is there, the square is x square, here is there, that is y square. This 2 is, they are getting cancelled. Now, xi plus yj divided by x square plus y square. So, the numerator which is written as it is. And we know it, what is the condition here which is given? X square plus y square, it's nothing but 16. So when we are substituting here root 16, which is equal to 4. So using this, we obtained this unit normal vector. So this is the figure, step by step, already we discussed it. Now, let R be the projection of S on YZ plane. So here YZ plane is there. Here the YZ plane is O, B, C, D. This is the formula for surface integral. There is double integral S f dot n ds, which is equal to double integral R. That is, R is the region. This f dot, which is written as it is. This ds is there. The ds we can write it dx dy divided by modulus of n dot I. Now, this is our given function f. So the vector f is zi plus xj minus 3y squared zk. Now we need f dot n to substitute here. First we will find out that. So f dot n, which is equal to completely f we have written here. The dot product as it is we have written. Already unit normal vector we discussed how. This is the result already we obtained it. So in the particular place we are substituting xi plus yj divided by 4. So the dot product we have done it. So this dot product we know it. I dot I exists, j dot j exists. So in this way these two we can multiply and these two we can multiply. So after multiplying, we obtained the result 1 by 4 of xz plus xy. Now, n dot I we are finding. This is also a term which is in the formula. This is our n, xi plus yj divided by 4, the dot which is written as it is, I vector. So the dot product only I dot I exists. So x into 1, x divided by 4. For j, there is no term at all. So it is neglected, which is vanished. Now, this is our x square plus y square equal to 16 in the yz plane. Now we are taking x equal to 0, which implies y equal to 4. That is, here in the place of x we are substituting 0. So we are obtained the value y equal to 4. Now in the first octant, y varies from 0 to 4. Then the surface integral is, this is the formula, that is f dot n dy dz divided by n dot I. Because ours is yz plane, here we have taken dy dz. Then, so totally x, y, z, we are surface integral towards yz we are evaluating. Then the third, the dimension which is perpendicular to this plane. So that dimension is x. Related to that, perpendicular mutually vector is I. So that is the reason here n dot I which is selected. Now already in advance we calculated f dot n and we calculated this, we will write it as it is. But we know y, the integration from where to where it varies, and z also from where to where it varies already we calculated, and n dot I also which is calculated, that's here nothing but x by 4. So everything which is substituted here, so x by 4 we obtained it, but the formula which is in the denominator, that's what which is put it in the reciprocal form 4 by x. And we are noticing in this term x is common, it is there. So that x, this x both are cancelled. 4 which is cancelled. So we can see it. This place we substituted here. This which is written as it is. This n dot I we obtained 4 by x. X by 4 we obtained. So it is in the denominator. So we brought it up 4 by x. Now the simplifying, we obtained y plus z is the remaining term after the common terms are getting cancelled. So d is a dy. Z varies from 0 to 5. This is the condition which is given in the question itself. And y from 0 to 4, this we obtained from the question, that is x square plus y square equal to 16, from which we obtained y varies from 0 to 4. Now, this y into here is there. We can write it double integral. Inside, two terms are there. For y purpose, we are writing the double integral. And z purpose, again we are writing the double integral. So the next one is, we have to do the integration. That is, here y dy, we have written here. This is dz. Regarding that range limit integral which is kept, 0 to 5 for z, for y purpose 0 to 4. So the first integral, we have done it here. The second integral also the same one here, dy, which is y from 0 to 4, whereas z, it has z dz, which is written 0 to 4. So in such a way, writing also we can do the integration, which is very easy for us. Now y dy is there. We know the integration formula, that is integral of x power n dx, which is equal to x power n plus 1 by n plus 1. Here the y power is 1, it is there. So if you substitute here, we will be obtaining, that is dy, y power 1 is pi square by 2. Here only dz is there, so the integration is z. Here only dy is there, integration is y. Whereas we will apply here for this formula, that is z, the integration is z square by 2. So we can see it here, what we discussed here, the previous slide, which is kept here, y square by 2, the range limit from 0 to 4. The second one, the integration is z, so the range limit is 0 to 5. So the next one is y, so the range limit is 0 to 4. So the last one is z power 1, that integration is z square by 2 from 0 to 5. So now we will substitute the limit values. So the upper limit, in the place of y, we are substituting 16. So 16 by 2, 8 we obtained it. So z place the upper limit, we are substituting 5. We obtained 5. Anyway, the lower limits are 0. So the result is 0. It is vanished. Then we will move to the next one. So the y, the place the upper limit 4, we substituted here. And here we are substituting z place 5. So 25 by 2, it is written 12.5. So totally we obtained 40 plus 50, which is equal to 90. So we evaluated this problems regarding surface integral. The result is 90. Next, we will move to another problem, that is evaluate double integral S f dot n ds, where capital F equal to yzi plus 2y square j plus xz square k. This is the function which is given, and capital S is the surface, that is x square plus y square equal to 9, contained in the first octant between z equal to 0 and z equal to 2. So now we will move to the solution, that is, so the given function is, so we can see the question condition. So the capital F equal to yzi plus 2y square j plus xz square k. This is our pi, that is pi equal to x square plus y square equal to 9. And z varies from 0 to 2. The function is different, mostly almost similar to the previous problem, but units are different and function also completely different. So the integral also evaluating also, we will be getting a different value. So now the normal to the surface, our capital S, is grade pi, that is a gradient pi. Now the normal vector, that is which is perpendicular to our surface, is gradient pi. That here gradient pi, the gradient is nothing but I into dou by dou x plus j into dou by dou y plus k into dou by dou z, the pi which is kept out. So the next step, we have taken pi inside. Here I, j, k should be there, because here only pi we are taking. So I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So we know it, our surface x square plus y square equal to 9, which is given, in which we are going to calculate x square, that is with respect to x partially doing, we are getting 2x, and next this completely with respect to y we are doing partially, so we obtained 2yj. So the unit normal vector, that is the given vector, to convert it into the normal vector unit, the formula is the particular vector divided by its modulus. So we obtained 2xi plus 2yj is our normal vector, in which 2 is common, we have taken outside. Now this modulus of this numerator, what is there, that vector we are going to do it. So the 2 which is written as it is, square root of x square, square root of y square. So simplification is this getting cancelled, xi plus yj divided by square root of x square plus y square. So already we obtained, that is the condition which is given in the problem, that is x square plus y square equal to 9. So if you are substituting here, square root of 9 is nothing but 3. So using this condition, we obtained this result. Next, let R be the projection of S on the YZ plane. So this is the surface integral formula, that is double integral over surface f dot n ds, which is equal to which region we are going to find the capital R represents, whether it is YZ or XY or ZX. So which region that is capital R represents, and F dot N dy dz, so y is a plane, then x dimension related to the mutual perpendicular vector which is normal to our surface, so n dot I. So what are the terms are there in the formula to substitute? First, that calculating part we will concentrate now. For that, here f dot n is there. F we are writing here. The dot is written as it is, and n already we calculated, that is written here. Then we have to do the dot product. So the dot product is I dot I, j dot j exist, I dot I, j dot j exist, whereas k there is no term at all, so it is vanished. Now, so these two multiplying x, y, z, this 3 we have taken common out, 1 by 3. These two we multiplied, 2y square into y, 2y cube. Next we are evaluating n dot I. This is our n, that is a normal vector, dot I. So this, which is a surface, what is the condition which is given in the equation, we put it here in the YZ plane. Now n dot I, we have to do the calculating part. If you do this calculating part, we are getting x by 3. Now, when x equal to 0, that is we have x square plus y square equal to 9. If you put in that particular equation in the place x equal to 0, we are obtaining y square equal to 9. So y equal to 3. That's what which is written here. So now completely the problem which is in the first octant, that is positive. So that is the reason we are taking only the positive value, because y square equal to 9, y equal to plus or minus 3, but minus 3 we are neglecting. We have taken the positive one, so 0 to 3. So the next one is z varies from 0 to 2. This is which is given in the question, the problem, that is a condition itself. So the next one is, then the surface integral is. This is the formula for the surface integral. F dot n completely, dy dz, which is written as it is. This we obtained it x by 3. It is in the denominator. We brought it up. So the reciprocal format which is written 3 by x. This completely cancelled. Next, we obtained now after cancelling xyz plus 2y cube 1 by x. This 1 by x we will take it inside. So if you are taking inside xyz by x plus 2y cube divided by x, here cancelled. So the first term we have got it y is it, whereas the second one is 2y cube by x. We can see it now. So what we discussed now, which is kept here, and it's the region double integral, which is used to calculate the area of the surface. For that, the z, the dimension, varies from 0 to 2, and y varies from 0 to 3. So we can see here, that is now we are going to concentrate integration with respect to z. So where I am circling, this we are going to concentrate. The leftover, this and this, we didn't touch at all, just we have written, just we copied from there. The circled one, we are going to do the integration. So y, z is there. So z integration is z square by 2, which is written here, and 2y cube by x. So dz, the integration is z from 0 to 2. So we completed the integration and 0 to 2. So we can see here, there's the first one, the interior integration we completed. After completing, the upper limit is 2. So in the place of z, we are substituting. So 4 by 2, so it is becoming 2y. Whereas here z place we are substituting 2. So it has become 4y cube by x. So we completed the interior integration. Integration part is over. Even the substitution also over. Only the upper limit is considered because it has the value 2, whereas the lower limit is 0, and each term z is there, so completely it is vanished. So regarding the interior integration, the work is over. Now we obtained 2y plus 4y cube divided by square root of 9 minus y square dy. The outermost one is from y equal to 0 to 3. This y, that is, we will do the integration, that is y square by 2. That 2 both are getting cancelled, so we have written y square. Here 0 to 3 plus 4 integral 0 to 3 y cube by square root of 9 minus y square dy. This integration is very easy one. We did the integration, and if you substitute also, the value is 9. But here this integration is very difficult to do it. Whenever the circle curves are there, if you do in polar form, we will be more comfortable. For that, we are assuming y equal to, we assumed y equal to 3 sine theta, and both the sides we are doing the differentiation. We obtained dy equal to 3 cos theta d theta. Now we are putting, so when we are, that is the integration rule, when we are assuming the substitution method, we have to check there will be a changes in the limits also. So we have our lower limit is y equal to 0. So in this particular place, we are substituting y equal to 0. Then left side is 0. The right side is 3 sine theta. Just we brought this 3 also this side. We obtained 0 equal to sine theta. When we will be in terms of trigonometry, the term 0 value. Sine 0 is 0. The right side we didn't touch. Just we are writing and we are coming. The next thing, we can equate to the terms. So we obtained the theta value is 0. So this part we checked it and we obtained theta equal to 0 because we are going to convert it into polar form. So next, substitution method we are going to do it. In polar form, y equal to 0. Sorry, y equal to 0 already we completed. Now the upper limit y equal to 3. So in this particular place, we are substituting y equal to 3. So we obtained 3 equal to 3 sine theta. So the 3 we are bringing here, 1 equal to sine theta, and this 1 value is nothing but sine 90. That is sine pi by 2, which is equal to sine theta. So from which we can obtain the result theta equal to pi by 2. So when y equal to 0, we got the result theta equal to 0. When y equal to 3, we obtained that is 90 degree pi by 2. Here we will substitute, that is y cube, it is there. So if it is y cube, y equal to 3 sine theta we have taken. So in this place we are going to substitute. That is here y place we are substituting this one. So 27 sine cube theta. Here we are going to substitute x square plus y square equal to 9. So 9 minus y square equal to, we know it, x square. This simplifications only, here we can see it, 27, 9 minus 9, this is sine square. That is here we substituted 3 sine square is 9 sine square theta. This is dy, y equal to r sine theta, so dy is 3 cos theta d theta. This is nothing but in which 9 is common. The square root of 9, it has become 3. So the remaining one is square root of 1 minus sine square theta. It is a trigonometric identity, that is cos theta. Already the top cos theta is there. Before step itself, 3 we cancelled it. So now the leftover only the numerator part, that is 27 sine cube theta d theta, and theta range from 0 to 90 degree pi by 2. So finally we obtained, that is the integration from the theta lies between 0 to 90 degree, 27 sine cube theta d theta. Yeah, so far we have did the integration. We have to do the concentration now. So 27 integral theta from 0 to pi by 2, 1 by 4 of that is sine cube theta we replaced by the corresponding trigonometric formula, that is 1 by 4 of 3 sine theta minus sine 3 theta d theta. So we will do the integration now. This 4 we have taken out. So it has become 27 by 4 and 3 sine theta it is there. So sine theta, the integration is minus cos theta. So minus 3 cos theta, and here the minus sign is there. Sine 3 theta, that is minus cos 3 theta. Already minus sign is there. So plus, and the coefficient of theta is, which is written, divided by 3 position. The range, the integral from 0 to pi by 2. Now the upper limit, in the place of theta we will substitute pi by 2. So here cos 90, here also cos 270. It's nothing but cos 270 can be written as 180 plus 90. So it's nothing but cos 90. So put together the upper limit, the value is 0. This is the limit formula. And now concentrating on the lower limit value 0. That is cos 0. The theta place we are substituting 0. So it is totally cos 0 value is 1. 1 into minus 3, minus 3. And here also cos 0 value is 1 plus 1 by 3. So this is 27 by 4, and here minus 8 by 3, outside minus is there. It is 8 by 3. Now cross multiplying, here we can see it 9 and cutting, we obtained the result 18. So now the integral is 4 integral y from 0 to 3 y cube divided by square root of 9 minus y square dy. So 4 into this part completely, we got the result 18, so 72. So the complete, actually this integral up to here we obtained the result 9. For this we obtained the result 18 into 4, 72 we obtained it. So 81, 9 plus 72, which is equal to 81, is the result of the second problem, that is evaluating surface integral. The result is 81. So the last problem we will discuss now. Find the surface area of the plane. That is x plus 2y plus 2z, which is equal to 12, cut off by x equal to 0, y equal to 0, and x square plus y square equal to 16. Solution. So now we will take the capital F of x comma y comma z, which is written here. We have taken, just we brought the 12 to the left position. It has become x plus 2y plus 2z minus 12, which is equal to 0. Now this is capital Fx, which can be written as dou f by dou x. So here x variable, we have to do the differentiation, that is 1. Fy. So here the variable is y, the differentiation is 2. Now Fz. Here the variable we have to see it, then that is 2. So we can see here completely, that is, before the two problems what we have discussed, the formula is double integral surface f dot n ds. Using that formula, first we found it f dot n. Then what is the dimension? Y is z plane. So far we discussed the two problems, dy dz. Then the x direction related to the mutually perpendicular vector. I is perpendicular normal to the surface. Using that direction we went. This same, the surface integral, this way also possible to do it. That is fx, fy, fz. Fx, it's nothing but dou f by dou x. Completely in the terms of y and z also we did. And we are going to find the square root of, here this fx is 1 square, here 2 square, here 2 square. So the square root of 9 equal to 3. This is the formula we are going to substitute. So this already the value what we obtained is 3. We can see it here. The value completely we obtained it 3. Here x, y, z it is there. And the dimension is dx dy. So the totally 3 dimension, xy it is there. Then the third direction is z-axis. So that's what which is written. Suppose in case here dy dz is there, the another direction which will be written down modulus of. So now what we obtained the result, this is 3, and here modulus of f is it, that is 2 square, square root of 2 square, it's nothing but 2. So 3 by 2 dx dy. Now the 3 by 2 we kept it outside. This can be solved in Cartesian also, but here we are taking the polar form, that is dx dy Jacobian of r into dr d theta, that is dx dy, which is in Cartesian form, we converted into polar form. Now the radius if you are taking, that is from 0 to 4 it varies, and theta from 0 to pi by 2. So here 3 by 2 it is there. Now we are not actually touching the outermost integration. Here, the outermost integration we have written as it is, but the interior integration coming to the point, here r is there. The simple integral formula x power n dx, which is equal to x power n plus 1 by n plus 1. So r square by 2 from 0 to 4. So 16 by 2, upper limit we substituted, it has become 8. So we have taken the 4 outside, the 12 we obtained it, 0 to pi by 2 d theta. So the 12 of d theta, the integral is theta from 0 to pi by 2. So 12 into pi by 2. So 12 into pi by 2 cutting, we are getting 6 pi. So far we concentrated 3 problems. Now we will come to a conclusion of this topic, problems on surface integrals, for which the definition of surface integrals, that is double integral, which is used to evaluate area of the surface, that is surface integral. Integral over S f dot and ds is the formula for this surface integral. Now we have taken a vector function zi plus xj minus 3y squared zk and the curve, the condition which is given x square plus y square equal to 16, and we evaluated the surface integral for which we have taken the yz plane. Another also we have taken the function which is yzi plus 2y square j plus xz square k, for which x square plus y square equal to 9, and for this here the integral to solve in a very easy manner we adopted this particular one in polar form. Then the third problem, it's a very different one. We applied surface integral in a different way. Using this formula, we solved it. So completely in this video lecture, we discussed about surface integral problems. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.